Good morning all. Now we will solve one problem on maximum power transfer theorem. Okay, determine the load resistance RL, okay, when maximum power is transferred from source to load, and also determine the maximum power. Okay, this is the given circuit. Okay, in the circuit, first of all I need to calculate load resistance RL. Okay, this value is unknown, right? But here he is given one condition. What is the condition? In question only is mentioned, right? Determine the load resistance RL when maximum power is transferred from source to load, right? Okay, the maximum power is transferred from source to load when RL is equals to RS or RL is equals to RTH, then only maximum amount of power is transferred, right? That means indirectly, if you calculate RTH across these two terminals, that RTH is equals to RL. That is the condition indirectly is given. That means here we need to calculate Thevenin's equivalent resistance across these two terminals by removing load resistance RL. Okay, calculate RTH. That RTH is equals to RL. Why? Because what is the condition is given? Maximum amount of power is transferred from source to load. Okay, that means maximum power is transferred from source to load when load resistance is equals to Thevenin's equivalent resistance, then only maximum amount of power is transferred from source to load. That means here if I calculate Thevenin's equivalent resistance, that is equals to load resistance RL. That's it. That means to calculate that load resistance, first remove this load resistance RL. Okay, if the circuit is having voltage source, that should be replaced by short circuit, right? Okay, see here I need to calculate RTH. To calculate RTH, voltage source should be replaced by short circuit. Now the equivalent circuit will be like this. Okay, now see here 10 ohm and 10 ohm are connected in parallel. That is 10 into 10 by 10 plus 10. Then the resultant value will be 5 ohms. Right? After that, these two resistors are replaced by single resistor. 5 ohm and 5 ohm are connected in series. Right? Then RTH is equals to 5 plus 5. RTH that is equals to RL, that is equals to 10 ohms. First bit is completed. Next calculate, determine the maximum power also. Okay, what is the formula? P maximum is equals to VTH square by 4 into RL. Already we know RL, right? Now here I need to calculate VTH. Okay, how to calculate VTH? Already we know, right? Same circuit, again redraw the circuit. Step 1, remove the load resistance RL. Okay, across removed resistance we need to calculate VTH or VOC, right? That means here I need to calculate VTH or VOC. Okay, while calculating VTH, current flowing through this branch will be 0, 5 ohms, 10 ohm, 10 ohm, 5 volts, right? Then VTH is nothing but voltage across 10 ohms, that is equals to, these three are connected in series. Then by using voltage division rule I can calculate voltage across 10 ohm, that is total supply voltage into that particular branch resistance divided by sum of series branch elements. I will get 2.5 volts, right? VTH value. Then P maximum is equals to VTH square by 4 into RL, right? Okay, what is the value of VTH? 2.5 right here. 2.5 whole square into 2.5 whole square divided by 4 into RL value how much? 10. That is 2.5 into 2.5 by 4 into 10, right? 2.5 fours are right. That is P maximum is equals to 2.5 by 16 watts. If you simplify, you will get the maximum power. Okay, in this way we can solve problems on maximum power transfer theorem. Okay, thank you all.